Okay. Same instructions. Simplify the expressions if possible. So again, don't assume that they're not like radicals and you can't do anything. See if there's any information we can take out. So they're both cubed roots. It's a good start. But we don't have a denominator, so we don't rule about rule 2 or rule 3. When we look at this, though, we have to be able to access all types of information. We've talked about what a like term is. Don't forget that there are things you should be able to recognize. We have to remove factors. That's rule 1. Factors. We remove factors. With these items here, with the negatives, it tells us that we have terms. So we can't just say, hey, there's an x cubed there, we'll take it out. These are terms of the expressions. So what we want to do when we see pluses or minuses in here, and we saw this with when we started doing the nth root of a to the n, the very first start of the stuff, we have to look to factor expression, possibly. So if I go through and I factor this expression, don't forget the first thing. After descending order, we look for a greatest common factor. Okay? If it's got a trinomial, then we look for sets of parentheses and those items. Difference of squares, difference of cubes, etc. 4 terms we look to factor by grouping. But don't overlook greatest common factor. Between these two, I know the greatest common factor is x cubed. And I need to multiply that by x minus 1. Okay? So over here, it's in descending order, look for the greatest common factor, which is 8, and I need x minus 1. Well, we're on the right track to have the same radical. I see an x minus 1 and a radicand. I see an x minus 1 and x minus 1, but these do not match. But so happens that, remember, this is a product, so we could split this up. This times this. Power matches index. I can take out an x. That's outside the radical. X minus 1 is to the first, so that's got to stay inside the radical. Now, if that was a 3, we could take that out as well. Over here, 8 I know is 2 cubed. So I can take out that 2. Fortunately, again, that's still the first, so that stays inside. So when we went through and we did the factorization, took out the factors that we could, we have something like this. Cubed root of x minus 1, cubed root of x minus 1. The radicands and the indexes match. Those are like radicals. But again, like the last problem, we have to look out in front. If you take away the radicals, okay, these have to be like terms as well for us to combine down to one item. Well, x and 2 are not like terms. If this is a number, I could add it to that. If that was an x, I would add the coefficients. These are not like terms. But we can simplify down to one expression. Right now I have one expression. Here's the second expression. When we have like radicals, what we can do when we have items out front that are not the same, we can group those together. X plus 2. And then we can list the common like radical. This is one expression versus leaving it like this. So in textbooks, when you go through and say, why do they put these in parentheses? They put these in parentheses to group the coefficients that were not like terms times that common radical. So if you see that, that's the reason why. So basically, they factored out the like radical and grouped the coefficients in front. Okay. So let's give you your third U-try problem here. Fourth root. 512 x to the fifth minus fourth root 32 x to the fifth plus the fourth root 1250 x to the fifth. This is U-try number 3. Okay, so the fourth root of 512 x to the fifth minus the fourth root of 32 x to the fifth plus the fourth root of 1250 x to the fifth. All the indexes match. can you get these to be the same radicand? Now, once you do the x to the fifth, do it once, you've done it for all the other ones. The numbers I've told you is where students struggle. This is why I give you this one, because I need you to practice that. We'll pick this up in the you try solution number 3.